Okay, here we'll be looking at when f of x is an exponential function. In our previous video, we've considered when f of x is a constant, when f of x is a polynomial. Here we'll be looking at when it is a what? It is an exponential function. Okay, now let's look at the definition. If f of x is equal to a exponential bx, then the yp, that's the particular function, is equal to capital A. This capital A is a constant, exponential bx. The exponential bx is the same. Are you with me? But this a, which is the constant attached to your exponential, is not the same thing as this capital A. This capital A is just ordinary constant, irrespective of what is here. Are you with me? Okay, that's our y of p. But we now put a condition by saying if m is equal to b, the power of our exponential here is b. Now, if you solve your auxiliary equation, that's your yc, complementary function, and you end up having one of your roots to be the same value with our b here. Are you with me? What I'm trying to say is when you solve your yc, your yc will be a exponential mx plus b exponential mx, or your yc is the same thing as a plus bx exponential mx. Are you with me? Or if your this m here is the same thing as the b on the initial question on the f of x, then there will be a problem. Therefore, you have to change your what? Your yp to what? Ax exponential bx. But should in case you changing it to this is for this when one of the m is b. But if your m is equal to b and m occur k times, for example, to consider this, it means m occur twice. So this part is when your m occur twice. So if m occur twice here, it means, for example, this is when you have real and equal. It means my m is equal to b. Also, m is equal to b. At this point, m had occur more than once. So if m occur twice or k times, then it means your yp will be ax raised to power k. That's numbers of time ym occur. Here you get. So if it is real and equal, it means m occur twice, then it will be ax raised to power 2 exponential bx. But for this one, since m is equal to b just for 1, then it will be ordinary ax exponential bx. Here you get. Okay, so that's how to consider our yp, that's particular solution. But let's try to look into example whereby the f of x will just be ordinary a exponential bx. We'll look at another example where m is equal to b, and at the same time we'll look at another example where m is equal to b twice or k times. Here you get. So it means under this exponential function we'll be considering 3 examples. Okay, now let's start, please. Example 1. Solve d square y over dx square plus 5 dy dx plus 6y is equal to exponential x. Okay, now look at this question. To solve this second order question, from the look of the question, I know it is second order, and then from this part, I know it is what? Inhomogeneous. But our f of x is an exponential function, so I can express the question in terms of d operator by saying it's the same thing as d square plus 5d plus 6y is equal to what? Exponential x. So I'll first look for my yc. The general solution remains the same. Our general solution is y is equal to yc plus yp. So let's start with yc. To find the yc, I'll have to take this to what? Auxiliary equation, which is the same thing as m squared plus 5m plus d equal m plus 6 equal to 0. Now, when we solve that quadratic equation, we end up having m to be equal to minus 2 and then m to be equal to minus 3. Okay? Now, at this point, it means our yc, my yc is the same thing as a exponential minus 2x plus b exponential minus 3x. Okay? Now, let's look for yp. Our yp is the same thing as, since f of x, let's start with that. Since f of x is equal to exponential x, then my yp is the same thing as what? A exponential x. So I can say that from d operator, my d operator, which is d square plus 5d plus 6y, which is same thing as exponential, right? Now we are looking for d operator, particular integral, particular solution. Then this y will be what? Yp to be what? Exponential x. But what is my yp? My yp is a exponential x. So I have it to be d squared plus 5d plus 6 yp. What is my yp? Capital A exponential x is equal to exponential x. Okay, now what is the meaning of this? It means d squared, that's second derivative of what is here, d, that's first derivative of what is here, and ordinary multiplication of this. So I can just write it as d square into bracket a exponential x plus 5d into bracket a exponential x plus 6, we multiply it, that's 6a exponential x is equal to exponential x. Okay, now let's differentiate that. If I differentiate, a is a constant. If I differentiate exponential a, x twice is still exponential x. So if I differentiate a exponential x twice, is still a exponential x. So what is there is the same thing as a exponential x plus, if you differentiate a exponential a once, is the same thing as a exponential x. But there's 5 multiplying it. So that will give us 5a exponential x plus 6a exponential x is equal to exponential x. If I add it up, that's 12a exponential x is equal to exponential x. This cancels this. 12a is equal to 1. A is equal to 1 over 2. Therefore, my yp, which is the same thing as a exponential x, is the same thing as 12 exponential, sorry, not 12, 1 over 12. This is 1 over 12, sorry, 1 over 12. So that's 1 over 12 exponential x. So my yp is this, my yc is this. And what is the general solution? The general solution is y is equal to yc plus yp. Therefore, our answer is y is equal to a exponential minus 2x plus b exponential minus 3x plus 1 over 12 exponential x. Final answer. So that's how we solve it if it is of exponential function.